In this video, we're going to take a look at section 7.2 on solving quadratic equations using the quadratic formula. To solve the equation ax squared plus bx plus c equals 0, you can use the quadratic formula, which is given here. X equals negative b plus or minus the square root of b squared minus 4ac, that whole thing over 2a. The equation has to be set up in the way that you see here. It has to be equal to 0, and it has to be multiplied out like this before you can identify a, b, and c. Let's try that again. A, b, and c. All right. And then once you identify a, b, and c, you plug them into this formula, and you simplify, and that gives you the solution to the equation. So what's happening here, the way you get this formula is you apply the completing the square process to this equation. So you'll subtract the c over here. You actually have to get rid of the a by dividing it through everything. And then you take b, divide it by 2, you square it, you add it to both sides. If you do all of that with a, b, and c and solve it for x, this is what you get. You get the quadratic formula. So it's really taking this equation, completing the square with it. I'm not going to go through the details because most students don't really appreciate it anyway. So they just want to know, what's the formula I need to know? How do I use it? And that's what we're going to focus on here. If you're interested in how you get the quadratic formula, I'm sure there's plenty of videos on YouTube that would show you the process for deriving it. All right, so once you've identified a, b, and c, you plug them in, you simplify. All right, so let's go ahead and practice doing that a few times. So we have x squared plus 14x plus 4 equals 0. So that's important. It has to be equal to 0 before we can identify a, b, and c. There's no number here, which means a is equal to 1, b is equal to 14, c is equal to 4. The first thing I would check for before using the quadratic formula is, can I factor this? Because if you can factor it, I wouldn't use the quadratic formula. I would just solve it by factoring. To factor this, we'd have to find two numbers that multiply to 4 and add to 14. And obviously, we're not going to come up with two numbers that do that. So we'll have to use the quadratic formula since there's no way to factor it by that process, right? So because we can't find two numbers that multiply to 4 and add to 14, we're not going to be able to factor this thing. Which means the only way to solve it is to use the quadratic formula. Or you could use completing the square, the process we learned in the last video. But today we're focusing on, or in this video I should say, might be the same day as the previous video for you. We are focusing on practicing using the quadratic formula. Right? So the quadratic formula is x equals negative b plus or minus. You need to memorize this, especially if you're in my class. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Right. So we take the numbers we've identified up here and we plug them into this formula. So we're going to have x equals negative b, which is 14, plus or minus the square root of 14 squared minus 4 times a, which is 1, times c, which is 4. Go ahead and get that square root over a little bit further. Divided by 2 times a, which is 1. All right, there's our solution. So I really can't emphasize enough how spectacular this formula really is, because it completes the square for you. It solves the equation for x for you. All you have to do is dump the numbers in, and it immediately solves the equation for you. So it really is quite a phenomenal thing. The only drawback is the solution is a big mess, right? You can't leave the answer like this. This is the solution, but it's all messy. So we need to simplify it, and that's where all the work is going to come in for us. We'll have to take time to simplify it, reduce the fraction, a lot of other stuff that we're going to have to do. The first thing you want to focus on, though, is the square root, right? So 14 squared is going to be 196. So I'll just rewrite everything else. Negative 14 plus or minus the square root. This will be 196 minus 4 times 1 times 4 will be positive 16, right? Over 2 times 1, which is 2. So it doesn't take long for this to get in pretty good shape, right? We'll keep working on the square root. We have x equals negative 14 plus or minus the square root of 180, right? Because 196 minus 16 will be 180 over 2. Now you can't reduce this because we learned this back in chapter 5, you can only cancel out factors. So the 14 and the 2 cannot be reduced with each other because the 14 is a term. If you want to cancel out the 2, you have to be able to factor a 2 out. And then you could cancel out that 2 with this 2. But you cannot factor a 2 out of the square root. Nothing's allowed to come out of the square root unless we simplify it and get something out that way, which is what we need to do here. So we want to split up the 180. This one's kind of tricky. 4 would work, but we can do better than 4. You want to get the biggest number possible that you can bring out of the square root, and I think it's going to be 36. And the only reason I'm able to catch that fairly quickly here, I think we might have saw this on a previous video in chapter 6, so that might be one reason why I'm thinking of it right away. But also another thing that popped in my head just now is, well, 360, sorry, I'm saying the wrong thing. 36 times 10 would be 360. 180 is half of that. So if 36 goes into 360, 36 will definitely go into 180 as well. And 36 is a good number to have here. And so 36 times 10 would be 360. Since this is half of 360, I'll take half of 10 here, which will be 5. So 36 times 5 is what gives me the 180. And then we apply the square root to each of those separately. So we'll get x equals negative 14 plus or minus 6 square root of 5 over 2. And we could factor a 2 out to cancel it out with the denominator, or you could just do this. Divide the 2 into each term separately. So we'll get x equals negative 14 over 2 plus or minus 6 square root of 5 over 2. And then reduce in each case. So we'll get negative 7 plus or minus 3 square root of 5. And that'll be the solution here. All right. And again, we can leave it with plus or minus because splitting it up provides no benefit because these aren't like terms. So you will not be able to simplify it any further even if we wrote the plus and the minus sign separately. So we'll just leave it together as plus or minus, just like we talked about in the last video in 7.1. All right, so that's essentially how the quadratic formula works every time. I have a few more examples, but not too many because it gets kind of repetitive because it's really kind of the same thing every time. Something a little bit different about this problem is we have to get it equal to 0 first. So that b is not equal to 12. I see that mistake all the time on the test. Students right away just say, oh, that's A, that's B, that's C. It has to be equal to 0 first before you can make that call. So subtract the 12x back to the other side first. So we get x squared minus 12x plus 61 equals 0. Stop a moment to consider if it could be factored. I'd have to find two numbers that multiply to 61 but add to negative 12. And 61 definitely is not a very friendly number. And so that doesn't look like something that will factor. So I will go ahead and use the quadratic formula. So we have x equals negative b plus or minus. Again, you have to memorize this. So a good way to get to know this formula is to write it down every time that you need to use it. Don't just work off of a separate sheet of paper plugging the numbers in. Write the formula down from scratch every time and try to do it from memory if you can. You probably won't be able to the first couple of times, but eventually if you try enough times, you'll start to remember the different details of this formula, and then you can just write it down from memory. Right? So negative b plus or minus the square root of b squared minus 4ac, the whole thing. Make sure, another common mistake, students don't put that fraction bar all the way across. It needs to go from the negative b all the way across the square root. Right? So what are a, b, and c in this case? Well, a is going to be equal to 1 again. B is going to equal negative 12. C is equal to 61. So let's plug those numbers in. We'll have x equals negative. Now, whenever b is negative, there's a couple of pitfalls you have to be aware of. We have a negative sign in the formula, which is what I'm copying down here. And then b is negative 12 in this problem. So you get a double negative. So be careful about that. When b is negative, that first term here is going to be a double negative, which means it'll come out positive. Plus or minus the square root. Be careful here also. b is negative 12, and that is going to get squared. That whole thing, the negative and the 12, will get squared. Minus 4 times a, which is 1, times c, which is 61. The whole thing over 2 times a, which is 1. So again, it's really amazing. That's our solution, right? We take those three numbers, we plug them into our formula, and immediately we have the solution to our equation. But we need to simplify this solution because it's a big mess. All right, so let's go ahead and start working on that. As I mentioned already, the negative of negative 12 will be positive 12, plus or minus the square root. Negative 12 squared will be positive 144. I will often, commonly, it's, it's not like half the students, it's not that common, but when students do make a mistake, one common mistake that is made is having this as a negative 144. Because when they type this in their calculator, they type in negative 12 squared, and without parentheses, the calculator thinks the answer should be negative 144. So when you type this in your calculator to find the answer, you need to put parentheses around the negative 12 when you go to square that for it to do it the right way. And the answer should be positive 144. Minus 4 times, I put my calculator away because I was like, I shouldn't need it for this video, but I don't know, let me think about it for a moment. I think it's going to be 244, right? So 4 times 60 would be 240, but 61 means we need another 4 on top of that, so 244. Over 2 times 1, which is 2. All right, so keep going. We get 12 plus or minus the square root of negative 100 over 2. The square of a negative 100 actually simplifies really nicely, which in a way is kind of bad. We like answers to look nice, but if this didn't simplify, if this square root was just stuck the way it was, we'd be done right now. You can't cancel out the 12 and the 2. If that doesn't simplify, it's over. You just leave the answer like this. So in a way, I kind of hope for bad square roots that don't simplify, because then I'll be done sooner. Because that does simplify, I have a couple more steps I have to go. So the negative sign here becomes imaginary, right? So we'll get I times the square root of 100. And the square root of 100 is 10. So that's going to become 10i. So we get 12 plus or minus 10i over 2. And now the 2 can be just like we did in the last problem. The 2 divides into each term separately. So we'll get 12 over 2 plus or minus 10i over 2, which gives me my final answer of 6 plus or minus 5i. All right, and that'll be the final answer. And again, we can just leave it with the plus or minus because the 6 and the 5i are not like terms. And so they won't combine together if we separate the plus and the minus sign. So we might as well just leave them put together like this, with the plus and minus sign together. All right, let's take a look at another example. So we have 5x squared equals 11x minus 17. We have to get the equation equal to 0 first. You might be tempted to take the 5x squared and subtract it over here. That would seem like the easier thing to do. But my advice, whether you're factoring it or using the quadratic formula, whenever a is negative, it's difficult. It makes things different enough that it's easy to make mistakes with. So I don't like having a be a negative number. So I will do whatever I can to keep a as a positive number. So I want to keep this as a positive 5, which means I'm going to actually subtract the 11x and subtract the 17 over to the left-hand side. And so we'll get 5x squared minus 11x minus 17 equals 0. And I just think things go more smoothly when a is a positive number. That's just my preference. So you don't have to do that, but I do find when a is negative, students make more mistakes when they have a negative value for a. And I'm more likely to make a mistake. It tends to be more work for some reason when a is negative. So I think it's just better if a is positive. And it's okay to go out of your way to guarantee that. So a is going to be positive 5, b is negative 11, c is negative 17. We could consider maybe trying to factor this, but it would be the AC method. You'd have to do factor by grouping, which already seems like a lot of work in and of itself, even if it actually is possible. We don't even know if it could be factored that way. So I'm just going to opt for the quadratic formula here. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Sorry, got a little crooked there. I'm going to try to fit this down here. Let's see if it'll work. We have x equals negative from the formula. B is negative 11. So again, you get the double negative. Plus or minus the square root of negative 11 squared. Use parentheses around that. Minus 4 times a, which is 5. times c, which is negative 17. The whole thing over 2 times a, which is 5. All right, and there's your solution. So let's go ahead and simplify that solution to see what our answer looks like here. So we'll have x equals 11, positive 11, because the negatives cancel out, plus or minus negative 11 squared will be positive 121. And what's going to happen here, I kind of misspoke earlier. The way I usually think of this is negative 4 times 5 times negative 17. So we have two negatives here being multiplied together, which will make this a positive. And I'm definitely going to need a calculator for this. I kind of got by last time without it. I don't even know where I put my cell phone. 1 second here. Okay, here it is. All right. I need to get a calculator. I don't know what happened to all my calculators. Okay, so we'll have 4 times 5 times 17. It's going to be 304. Actually, I probably could have figured that out without a calculator. 340 over 2 times 5, which is 10. So we'll go ahead and add 340 plus 121, which gives me 461, which looks bad, right? We're like, oh, that's a scary number to have inside of a square root. But really, I'm thinking that actually might be for the best, because I'm thinking that doesn't simplify. All right, let's try that again. 461 over 10. And if that square root doesn't simplify, you're just done. You just stop right here. So I'm pretty sure 461 is not going to simplify. We could try some numbers. I know 9 doesn't work. I know 4 doesn't work. 16 is not going to work if 4 doesn't work. I don't know. I guess that's really not true. Yeah, no, I think that would be true. If 16 works, then 4 would have worked also, right? So 16 isn't going to work. 25 isn't going to work because it doesn't end in 5 or 0. 36, no, I don't think 36 will work if 4 doesn't work. 49, let's try that. 461 divided by 49. Nope, it's a decimal, so that doesn't work. 461 divided by 64. No, I don't think that's going to work. 461 divided by 81. No, that doesn't work if 9's not going to work. So it doesn't appear like any number, any good number is going to come out of 461 that would help us simplify this. So that means we're done. Like I said, it's kind of nice when that square root doesn't simplify. All right, so that's what you'd have to type into Math Excel. That's a little bit of a cumbersome thing to type in, but that would be the solution, the two solutions, right? So keep in mind with the plus or minus there, we actually are getting two answers. One answer with the plus sign, one answer with the minus sign. We just kind of keep them written together because writing them separately, there's no benefit. Nothing simplifies anyway, so we'll just keep them written together like this. All right, let's take a look at another example here. So, okay, this one, the setup of the equation's unfortunate. It's not even really a quadratic equation to start out here. It's a rational equation, which we haven't done in quite a while. Since chapter 5, I guess that wasn't too long ago. But remember what we do to deal with this situation is find the LCM, multiply it to both sides. The LCM isn't going to be too complicated here. It's just going to be 12x. We'll multiply 12x to both sides of the equation, so make sure you distribute it to everything, whether it's a fraction or not. So I'm going to multiply it to each of these things. So we'll get 12x times x, which will be 12x squared, plus, think of this as 12x over 1. 12x times 1 over x. The x's cancel out, and we just get 12. Equals, here the 12's cancel out, and we'll just get 25 times x. All right. So this case, the x's cancel out, and that's how we got 12. For the other case, we had 25 over 12 times 12x over 1. The 12's cancel out, and that's how we got 25x. All right. Now it's quadratic, because now we have x squared. And so I will subtract, I want to get it equal to 0, so I'll subtract the 25x over here. Get 12x squared minus 25x plus 12 equals 0. Now this one actually can be factored. Don't ask me how I can tell so easily. So you'd have to do the AC method. So we have A times C would be 12 times 12, which is 144. B is equal to negative 25. So if you can find two numbers that multiply to 144, but add to negative 25, you can factor this, and you don't have to use the quadratic formula. And that is possible here. So I'm trying to think, is that the way we want to go? Because I kind of want to illustrate what happens if you do use the quadratic formula here, because for this one, you do not want to use plus or minus in your final answer, because it can simplify to, some nice numbers. But yeah, I think I'm going to go ahead and do this, because my position is, even if the directions say use the quadratic formula, if you can factor it, you should solve it by factoring. That's my official position on these problems. So quadratic formula to me is a last resort. If I can't solve it by factoring, if I can't solve it by just taking the square root of both sides, then I use the quadratic formula because it's my last resort. I don't have another way to do it. So here, the two numbers, in case you're wondering, would be negative 16 and negative 9. Those multiply to positive 144. They add to negative 25. So remember, what we do with those two numbers is we split up the middle term and rewrite negative 25x as negative 16x minus 9x. So let's continue that over here. And so we'll have 12x squared minus 16x, and then we'll have negative 9x plus 12 equals 0. And now you do factor by grouping. So we'll group the first two terms together. And that's why I kind of left a little space here. Group the second two terms. The minus sign should stay with the 9 inside the second group. And you should always start with a plus sign between your two groups. The common factor in the first group is 4x. That's going to leave me with 3x minus 4. The common factor in the second group, I don't know why I put a plus sign there. We're going to factor out a negative with the common factor, which is 3. And that'll make this a 3x minus 4 as well. And since these are the same, and that's the critical piece for factoring by grouping to work here, is that these parentheses need to match each other. And they do, so we can factor that out. We'll factor out the 3x minus 4. That's going to leave me with 4x minus 3 inside parentheses. And so now I factored it, so now I can solve each of these by setting them equal to 0. Right? So we'll get 3x minus 4 equals 0, and 4x minus 3 equals 0. And then you solve each of these for x. I don't like skipping steps, but I'm out of room here, so I kind of just want to tell you the answer you should get from, because that's easy enough. You add 4, you divide by 3, right? And so here you're going to get x is equal to 4/3. And from this one, you'll add 3 and then divide by 4, and so you'll get x equals 3/4. Right? So I didn't write out the steps, but I at least verbally stated what they were. All right, and so those will be your two answers. Now, if you use the quadratic formula to solve this instead, you should still get the same two answers. And you should be able to write them separately like this. You don't want to use a plus or minus in this situation, right? Because they simplify, right? Because they simplify to these nice fractions. You don't want to leave it with a plus or minus in your answer. So if you want to solve this by quadratic formula, make sure that you split up the plus and the minus case separately and simplify in each individual case, and you should get 4/3 for one answer, 3/4 for the other answer. All right, let's take a look at this one. All right, so here, again, I would check about factoring. We'd have to do the AC method. So A times C here would be 3 times negative 5, which would be negative 15. B is equal to negative 7. So I'd have to find two numbers that multiply to negative 15 and add to negative 7. And that's not going to happen, right? The only numbers that really multiply to 15 are 3 and 5, and that doesn't add up to 7. And 15 and 1, which doesn't add up to 7. So this does not factor, which means we have no choice. We have to use the quadratic formula here. It's already equal to 0, so we can go ahead and identify A is equal to 3, B is equal to negative 7, C is equal to negative 5. And so we'll have the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac over 2a. All right, so we'll plug the numbers in and we'll instantly have our solution. We'll have negative b, which is negative 7, plus or minus the square root of b squared, which will be negative 7 squared, minus 4 times a, which is 3, times c, which is negative 5. The whole thing divided by 2 times a, which is 3. There's our solution. So let's go ahead and simplify it so we can get a better idea of what the answer actually is. So negative of negative 7 becomes positive 7. plus or minus the square root of negative 7 squared will be positive 49. And again, negative 4 times 3 times negative 5 will come out positive, because negative times a negative is positive. And this will be 20 times 3, which will be 60. Over 2 times 3, which is 6. So we'll continue up here. We'll get x equals 7 plus or minus the square root of 109 over 6. So we're back to the pretty similar situation as the example we did a moment ago. Not the very last one, but the one before it, I think, where we get this pretty awful number inside the square root, which really is a good thing because I can't simplify square root of 109. So I will just leave it the way it is. And again, because it's a square root, it doesn't combine with the 7. There's no reason to split up the plus or minus when you're writing it like this. Again, with the square root in the answer, this would be the exact solution, which is one thing they're asking for here. So that is what you would type in as your exact solutions. I keep saying singular here, but remember, with plus or minus, there's two solutions there. But then they want the approximate solution to 3 decimal places. So I want to be able to plug this into my calculator. So I will have to go ahead and split this up and get the plus and the minus case separate for plugging it into my calculator. So one answer here is 7 plus the square root of 109 divided by 6. The other answer is 7 minus the square root of 109 divided by 6. So I'll go ahead and use my calculator since I had to use it earlier. And I'm using my iPhone calculator, which isn't the easiest one to use. And so I'll have to do the radical first. I mean, if you have a more scientific, standard calculator, you could just type in 7 plus square root of 109, enter, see what that is, and then divide that answer by 6. But with the iPhone calculator, I have to type in the number first, 109, and then square root that. And then I'll add 7, so I kind of have to do it backwards there. I'll add the 7 to that. And then I'll divide by the 6. So when you plug this into your calculator, what you should get for this one is 2.90. I have a 6 here, but then the number just to the right of it is 7, so I want to round it up. So the 6 will also get rounded up to a 7 here. All right. And so that's the 3 decimal places rounding it. And this is an approximate solution, right? It's a decimal approximation of this answer with the plus sign. We'll do the same thing with the minus sign, so let's start over again. I'm going to do 109 first. And take the square root of that. And then I want to do 7 minus that answer, which again on my cell phone calculator is not really easy to do. So I'm just going to do the opposite. I'm going to do that number minus 7, which again is going to give me the right number but the wrong sign. So my calculator is going to give me positive 3.44. It really is negative 3.44 if I flip these around the right way. And then I'll divide that by 6. So I'll just remember that my answer, even though in my calculator it's telling me positive, I know this answer should be negative. It should be the opposite sign of what I'm getting in my calculator because I subtracted these in the opposite order. And so it's going to be negative 0.573. And that would be the other approximate solution. All right, where we use the minus sign. Okay, so that's how you would approximate it. Do the plus and minus case separately, plug them both into your calculator to get the decimal approximations. All right, so this is the last example. Maybe this one's here for you guys to try. This would be where I would let my students try a problem in class. So pause the video, see if you can solve this equation by using the quadratic formula, and then resume the video to see if you came up with the correct solutions. So what you should do first is get it equal to 0 by subtracting the 1 back to the other side. It's really critical that you do that to get the right answer. All right. So that's the first step, is get it equal to 0. Then we can identify A, B, and C. So if you're identifying A, B, and C here, you're gonna think C is equal to 1. C is not equal to 1. C is equal to negative 1. A is equal to 2. B is equal to negative 9. So we'll plug those numbers into the quadratic formula. So we have negative b plus or minus the square root of b squared minus 4ac over 2a. All right, so let's plug these numbers in. We have, Again, a negative value for b, that's always the more difficult case. Be careful with those negative signs. We have the negative sign from the formula, and then b is negative 9, plus or minus the square root of negative 9 squared. Make sure you put that in parentheses when you type it in your calculator. Minus 4 times a, which is 2, times c, which is negative 1. Sorry about my square root symbol. It's got a little crazy there, but hopefully you understand what I'm doing. I don't know. I think it's a little too bad, actually. Let me just redo it. All right. Let's try that again. Okay, that's a little bit better. All right, and that's our solution, but now we want to simplify that to make it look a little more presentable. And so we'll have x equals negative of negative 9, which will be positive 9, plus or minus the square root of negative 9 squared is positive 81, plus 8 over 4. All right, so again, negative 4 times negative 1 times 2, that's going to be positive 4 times 2 times 1, which is 8. So we'll get x equals 9 plus or minus the square root of 89 over 4. And again, it's a horrible number to have in a square root, but that's a good thing because you can't simplify that, so you can't go any further with this problem, right? If you can't simplify the square root, you can't simplify the fraction, and so you just stop. You're done. This is what our two solutions look like. We have 9 plus the square root of 89 over 4, and 9 minus the square root of 89 over 4. All right, so that concludes the video on section 7.2 on solving quadratic equations using the quadratic formula.